So what you need to do is be the automaton yourself and experiment. Put in strings that consist of the 4 symbols, reset 0, 1, 2, and check that it does what it claims to do. So, like I was saying, when the automaton reads, if you like, the symbol reset, it puts the running sum back to 0. Okay, and its function effectively is that it accepts a string if the sum of the elements in that string is a multiple of 3. Okay, so you need to convince yourself that that's the case. It's not a trivial example. It's got lots of transitions and so forth. But you can analyse that for yourself as a bit of homework, if you like, and see that the automaton does do as it states here. Okay, now a double line, that usually means like a bit of a shift in topic. Now, sometimes, well, it happens quite often, your automaton is too complex. For example, it has too many states, or maybe there's some parameter that's not specified well. In other words, it's impractical, not practical, to write to draw, if you like, your automaton as a state transition or a state diagram. You can't really draw the state diagram. It's just not practical. Because there, well, like I say, too many states, or some parameter is not specified well enough. So in that case, what do? Well, remember you got 2 ways to specify an automaton. One is the more informal way. That's to do just to sketch it as a state diagram. Now you can do that if the number of states is small, as we've been doing so far. But as the number of states becomes large, that's not practical. And you might have a parameter that is not well specified. It might take an infinite number of values, and in that case, there's no way you can draw it, right? You can't. So what do? Well, then you use the other alternative, the other way to specify an automaton, to define it. And that's the formal definition. In other words, the 5 tuple. Remember? The 5 tuple. So an ordered 5 things. So Q, sigma, capital Q, capital sigma, little delta, little q naught, and capital F. Right? The 5 things. Okay. So. So if it's not practical to draw a state transition or state diagram, then you have to go the other way and write out a formal definition. Now, if you can draw a state diagram, it's sort of usually easier that way because it's sort of intuitive and visual, and you can sort of just see it, right? Well, I don't have an example here, but in some cases that's not practical, so therefore you just have to specify, describe your automaton by using the formal description, the 5 tuple with those 5 things I just mentioned. Okay, so here's an example where there's too many states. But particularly this case, where there's a parameter that's unspecified. You'll see what I mean in a moment. It's a little vague, but you'll get the idea fairly soon. Okay, so this is example now 1.15, and it's a generalization of exercise example 1.13. Now that was the summer to mod 3. the second example we did in the previous session. Okay? So example 1.15 is a generalization of that. And the generalization is that it's not mod 3, that was a concrete case, it's mod I, like as in IJK, where I is not specified, right? So, unspecified. So, it could be any positive integer, right? So how would you go about specifying, describing an automaton that is a kind of running counter mod I? So your input alphabet is the same. I think that's correct. Yeah, it uses the same alphabet. It's capital sigma. So the reset. I should have forgotten to put that here. So reset. Okay, 0, 1, 2. So the alphabet, the input alphabet's the same. And for any or for all I, integer I, greater or equal to 1, AI, now that's often a symbol for a language, it's the language, by definition, of all strings whose sum is a multiple of I. Now before it was a multiple of 3, right, up here. That was example 1.13. And this is example 1.15, which is a generalization of this. So instead of having 3 here, we now have I. Okay? So with the same input alphabet, these 4 symbols, right? So again, reset does the same thing. It just resets the running sum to 0 when it reads that symbol reset in the input stream. So just resets your running sum to nothing. Okay. Now for each alphabet AI, for a given I, we now need to create, define an automaton with that function for a given I. Now I is unspecified, so it's a generalization. So for any I, any positive integer, we now need to specify the automaton that would recognize the language whose strings, if you sum all the integers in the string, the noughts, the ones and the twos, you sum them all, that sum would be a multiple of I. Okay? That's the task, right? So we'll give a formal description, with the 5 terms, okay, that describe, find our automaton. We'll call it BI, because it depends on I, of course, okay, and that automaton BI will recognize the language AI, as I've just, right? So we need to now describe formally, with the 5 tuple, this automaton BI that recognizes the language AI. Okay. Right. So it's a bit after 5 p.m.